Welcome back. Welcome back to Learning with me at MPB for our Algebra 1 boot camp. I'm so glad that you came back. Today we're looking at Lesson 8, which is exponential functions. And we have a good many standards that we're going to be looking at today. So let's go ahead and dive in. Remember what exponential functions are, okay? They have a what? Y equals AB to the x. So we want to make sure that we're remembering what our formulas look like. We're going to look at some map problems today. So here we go. The power of staying calm. We want to make sure that when we're doing these different problems, we're staying calm, we're reading fully, we've got the ball, and we know what we're doing. So you've got this, just stay calm. Here we go. A record studio. A record studio charges musicians an initial fee of $60 to record an album. Studio time costs an additional $75 per hour. Which function represents the total cost in dollars, C of T, of recording an album as a function of studio time in T hours? So let's go ahead and annotate this problem and see what we've got. So here we go. So we have an initial fee of $60. We have an additional fee of $75 per. That's a big, big word. Which function represents the total cost, and then here's what we have. So let's just go ahead and write it down. So my total cost, now I am going to pay $60 no matter what. Even if I go in there for 2 seconds, I'm paying the $60 no matter what. Now, each hour that I'm in there, I'm paying $75 for every hour I'm there. So that's the per, and we learned that per means what? Multiplication. So how do I write that? Let me show you. I've got $75 per hour. So do we have one that looks like that or similar to that? Well, I know it's not that one because I'm not multiplying anything to 60. I'm not subtracting my initial fee. So obviously nope, that one can't be the answer either because again, I'm not multiplying anything to my 60. So this one has to be my answer. Good job. Let's look at the next one. Which scenario best represents the exponential growth, exponential decay, or neither? Select the box that describes each scenario as exponential growth, decay, or neither. So let's go ahead and read these. So it says an initial population of 15 hamsters doubles each year for 6 years. So if I'm doubling, I'm getting more hamsters, that means I'm what to my population? It's getting bigger, and that's growing. Good job. Sheila bought a car for $18,000. She expects the cars to lose value at a rate of 14% per year. So if I lose value, that means my amount is what? It's falling or decaying. Good job. Ella starts a track program by walking 2 miles. She increases her distance 3% each week. She increases, or she grows her percent of 3 each week, so it's going to be a growth. To take a taxi, it will cost Connor $2 for the first mile. After 5 miles, it will cost him a total of $6.50. Well, he's not growing, he's not decaying. We're just saying this is what he's paying and this is what he's paying. So it would be what? It would be neither. Good job. Last one. Membership at a fitness center declines at a rate of 5% per year. There were 125 members at the end of the first year. So it tells me it's declining. If something is declining, it's what? It is a decay. Good job. Let's remember geometric sequences, growth and decay, transformations of exponential functions. All of this we dealt with those exponential functions, what those geometric sequences were, how we used the different formulas for those. So we want to make sure that we're going back and reviewing those. With a set fee of $55, the total cost in dollars C to provide food for an event with P people is given by the function. C of P equals 16P plus 55. When the setup fee increases by $30, the new total cost in dollars T is given by the function T of P equals C of P plus 30. which statement is true? Okay, so we see that we had our initial fee of $55, and we had P number of people. So this was our first part. This was our first part. When the setup fee increased to $30, it increased by $30. So not only is it 55, but now it increased by 30. So my setup fee is now $85. So let's see. Let's look at these statements. The graph of T is a vertical translation 30 units up from the graph of C. The graph of T is a vertical translation down from C. The graph of T is a horizontal translation 30 units left of C. The graph of T is a horizontal translation 30 units right. Well, if I am moving this, which is away from my variable P, is that up or down? Yes, it would go up or down. But since I'm adding, I'm going to go which way? I'm going to go up. So A would be my answer. Notice how we went through the passage and then we went through each possible statement. You've got to make sure that you're understanding what it's asking and what possible answers it can have before you go back and say, okay, I have this, it can't be this, it can't be a translation left or right, it has to be up or down. So we want to make sure that we're really digging into these passages. All right, which ordered pair? Which ordered pairs are on the graph f of x equals 4 times 3 to the x? Select two answer choices. Now, we are going to use Desmos because right here is a perfect example of how we can use Desmos. So let's go ahead and put our equation in. So we had 4 times 3 to the x. Now, it wants to know which one of these possible are our answers. So what I'm going to do is I'm going to plug them in and then I'm going to have them appear on my graph. So let's see. The first one I had -1, 4 divided by 3. It is on my graph. The next one I had 0, 12. Let's see. It is not on my graph. All right. So then the next one is 1/2, 6. Let's see, 1/2, 6. Whoops. I guess if you put it in correctly, it will probably look a little better. All right. So we're going to take those out. We're going to scroll and then put our parentheses, then put our 6 and close. Nope, it's not. It's almost, but it's not quite there. All right, so we know that one's not it. So the next one is 2, 144. Oh, Miss Killen, there's no way that I can see that, is it? I don't know. Let's see. Whew, that is such a big number that I'm having a hard time. So, Miss Killen, is there another way that we could possibly do this? Because the last two have really big numbers. Yes, there is. We're going to put a table in. So let's watch. So I have my initial equation. So I'm going to hit my gear and press table. Now it shows me. So let's see. I want to put a 2. Well, it says 2 is at 36, so I know C is not my answer. What about x being 4? Well, 4 would be 324, and that's exactly what D tells us. So we have found out by plotting on our graph, plus looking at our table, just pulling the table and seeing what those different x values are, and we can find that our answer is A and E. That's a good use of that technology. Okay, so let's read the passage. The following question has 2 parts. First, answer part A, then answer part B. James deposits money into 2 different savings accounts. The table shows the balances in each account in 15-month intervals of time. Part A, which function best models each account? Select the box that matches each account with the correct function. Okay, so let's look at A first. I see as I go up every 15 months, I am increasing 150 for the first one, and then 150 for the second one, 150 for the third one, and 150 for the fourth one. So if I'm increasing the exact same between every point, that's going to be exactly right. It's going to be linear. So then let's look at the next one. Okay, the first one, I'm increasing $4.02. The second one, I'm increasing how much? Let's do this together. 33.70 minus 29.02. All right, so that's my next change. Then I have 39.12 minus 33.70, and then it is 5.42. So we can already see that there is not an exact change between each point. It's progressing, or it's exponentially growing. So we know that this is going to be an exponential function. Good job. Let's look at part B. It says, based on the account balance information, which statement is true? Account A and B both increase by equal factors over the same amount of time. Account A and B both increase by equal differences over the same amount of time. Account A increases by equal differences, and account B increases by an equal factor over the same amount of time. Account A increases by an equal factor, and account B increases by an equal difference over the same amount of time. So what we need to know is, obviously, they're not equal. It is not equal. And then they are both increasing by equal distances. Well, we know that it is not equal. So then I need to look at C and D. So the first one says A is increasing by equal differences. Well, the difference is what? We said was $1.50. Okay, so D also says about account A, it increases by an equal factor. Now remember, when we have factors, we multiply. When we difference, it's the exact same. So am I changing by a factor, or am I changing by the difference? I'm changing by the difference. So my answer would be C. Good job, guys. Really good to look at those different ways to see how we're changing and what we're doing in these different problems. Okay, let's see what Sam has to do. Sam has 3,250 followers on social media. His number of followers is decreasing at a rate of 3% per week. Which function represents his number of followers after W weeks? Well, if he is decreasing by 3%, how much of his followers are left? 97%. So obviously I don't see 97% over here, so I'm going to have to change this to a decimal by moving my decimal over. Okay, so I know this and this are not the answers. So then it says that he has this many followers after W weeks. So obviously I take how much it was and multiply by how many he had left for each week, and my answer is going to be A. Make sure that you're looking at that decreasing. Make sure that you're looking at that rate in percentages, and we're going to have to change that into decimals. You always want to remember those skills that we've learned beforehand. The following exponential function describes the growth of a certain plant cell in T hours. How many plant cells are there after 3/4 of an hour? So if T equals the amount of time and we're given 3/4 of an hour, so if I plug this exact thing into my calculator, what do I get? 24. Make sure that you remember how to put that exponent in with that exponent key. Good job. I'm so glad that you're reviewing with us and remembering what we've learned with us here at MPB. As always, have a great day.